All right, guys. So in this lesson, I'm gonna show you how you can also combine radicals to get a single radical in this form. So let me show you the examples I'm talking about. So for example, look at number one. Say you have to deal with maybe say the square root of a multiplied by the square root of let's say the fourth root of a to the third. I'm just saying something like that. Something like that. So how can you combine these two results, to get a single radical? So this is what you can do. So first, you have to know how to convert from a radical to exponent. I think that might be helpful, very helpful here, okay? This is what I'm going to do. So I'm going to convert a to the second, the square root of a to a to 1/2, okay? That's how you convert that. There's a 2 here, then there's a 1 there. So, and you know that this and root always divides the exponent, okay? That's what that is. So originally what we're dealing with was square root of a multiplied with fourth. So they're separate. They're not composed with each other like we had before on the previous example of part one. Okay, but this time you can see how they're separated from each other. So what you can do is to find a way to combine them so that you can make a single radical from there. And for this reason here, you have a 3 to be divided by 4. So it's going to be a to the 3 over 4. Remember that this always divides the exponent, okay? That's like 2 divides 1, right? So from there, I can just combine and choose one base, which is just the a. And then since I have multiplication, I'll just add up. So you add the exponents. From there, it'll be a to now 1/2 plus 3/4 is actually what you can do here is actually convert this. So what you can do is do 2 over 4 for 1/2. Make it easy to add it up with 3/4. Yes, just a algebra 1 skills. Okay, a to add that up with 5/4. Okay. Now from here you can convert it back to the radical form. So how do you convert this radical form? It'll be this 4 here is the root. Okay, is the nth root. Nth root. Let me write the correct spelling for it. Let me erase that. Okay, nth root. That's what the radical is. Okay, it's a 4, and this will be the exponent or index. So which means I'm gonna have 4th here. I'm gonna have a to the 5th here. Done. I'm gonna go to another example. This time maybe we can do something like a quotient. Let's do 3, a to the 4th. I'm gonna divide it by, let's say, 4th root of, let's say, a to the 3rd. I'm just saying, so I just did put this together. All right, let's see what this means. So in order to combine them, they do not have the same radicals. Like this is the third, this is the fourth. So you cannot just uh, combine them directly. So I'm going to write this in exponent form first. It could be a, and that's going to be 4/3. Remember that this 3 has to divide 4. And I'm going to divide that by a, then it'll be 4. This will be 3/4. Is the opposite of that. Okay. All right. So this is what I'm going to be doing. So from here, I'm just going to subtract exponents and keep the same base because it's division. So division would lead to subtracting exponents, okay? Just in case you can't see, that's a 3/4 right there. Doesn't look clear. Okay, so this is what I'm going to do. So you're going to keep 1, which just means a 4/3 is to be divided by a 3/4. So then if you have the same bases, you keep 1. Just like we did here when we had the same base, when we had the same base, we had to just choose a, and added up the exponent because you have multiplication. Now you have division, so you'll subtract 4 over 3 minus 3 over 4. All right, to do this type of math, all you gotta do is to kind of find a way to simplify this result. So I can multiply 3 by 4 and 4 by 4. And when I get here, I'll multiply with 3 and 3. So this is what I'm saying. So this becomes, if I multiply by 4, this becomes 16 on the top. Okay, and then the denominator will be times 4, which is 12. And then you minus, and this I'll be multiplying with 3 and with 3 here. Okay, so 3 times 3 is 9. And 4 times 3 is 12. I'm doing this so that I can have the common denominator, okay? Let's go down here. So you have A, 16 minus 9 is going to be, 16 minus 9 is going to be 7, okay? Yeah, 7. And then I have 12. That means 7, 12. So this can go back to a single radical now. I'm going to have A here. I'm going to have this 7 as the exponent. And I'm going to have this 12 as the end truth. So this would be your answer. So this is how you would combine situations like this. They're very different than if you had them this form and then you have where you just have 8 to the fourth and they have 3 here. It is very different, where you do it. Okay, you can then this is already combined, but these ones are not combined. They're separate from each other, so you have to do them separately and then convert them to exponents before you can find a single radical to represent them. I hope this is a little helpful. uh, go over them and repeat the video so that you can understand better. Thank you very much.